Good for them. That means somebody's paying attention. That doesn't mean I have to start all over again, does it? Okay, so let's talk about after the tendon's made and it goes into the chuck. If I were chucking up a piece of metal here, you know, and I brought it up and I kept it all on center, I would not have a problem. However, if I force this piece to be on center here, I'm not going to get a good grip down here. Anybody want to guess why? Here's the way I'm going to do it, and then we'll talk about why I do it this way. And if you don't want to do it this way, that's fine. It's just my way of doing it. I'm going to make sure that my center does not dig into this wood, but I'm going to put a little pressure on it, and then I'm going to tighten this thing up. That doesn't mean that it's going to run true. What it means is that I'm going to get the best grip here that I can get. And I'll explain to you why. If I were to take a basketball up here, and I held it here, and I put 10 pounds of pressure here, how much pressure would I have here? 10 pounds, okay? If I took a half a basketball and the other half was this memory foam, and I put 10 pounds of pressure here, and I put 10 pounds of pressure here, what would happen? The center wouldn't be in the center anymore, would it? If I made that thing stay in the same pin, one hand would be here and one hand would be here, and the ball would be out of center. When we chuck up a piece of wood, that wood is not uniform. Think of heartwood and sapwood, okay? Where the sapwood is obviously softer than the heartwood, and so when you start compressing these fibers, you're going to compress the sapwood more than you compress the heartwood. Also think of this. Think of that. This started out as a quarter of a log. So I've got a log here with a bunch of rings in it and a pith in the middle. I came along here and I quartered that log and I took a piece out of it right there. Now when I put a jaw here and I put a jaw here, on the edge of this grain running this way, they're probably going to pull pretty much the same amount of pressure because neither one of those two ends of that grain are going to compress. When I put a jaw here and I put a jaw here, they are not going to compress the same because the grain is denser here where the arcs are shorter, and it's softer here because I'm in the sapwood. So this piece of wood, to actually get all of these jaws to match, needs to be able to move, which means it's not going to be centered anymore. I turned it between centers. It's nice and round. I put it in my chuck, and it's not going to be centered anymore. Well, make a liar out of me. Okay, so the reason I'm doing this is because when I get way out here at this end without a center steady rest in it, I'm going to have a lot of pressure on the end of this thing, and I want the best grip I can get here. So that's the way I'm going to get the best grip that I can get out of my chuck, okay, assuming that I made my tendon correctly, and we're going to get to that in just a second. All right, so here's my piece. Here's my number 1 jaw, my number 4 jaw. I know that because I've got it marked here with my name. I put a pencil mark here, and I need to find my pencil while I'm thinking about it because I'm going to need it again. So I'll put a pencil mark right here. Later I'm going to try and align this grain again, so I'm going to want a pencil mark down here too. Doesn't have to be perfect. I'll line the grain up. I'm going to bring this up. If this were wobbling more than it's wobbling, let me check it. It's running pretty true. If it were wobbling more, I would take the center point out of my live center because I don't want that live center to pull it around. If I've got this piece now like this and it's wobbling like this, and I pull it back straight because this little point wants to go back in the center, what I'm going to do is somewhere along here, I'm going to pull a gap in one of these jaws. And that means when I get out here and I start hollowing, I'm going to have a lot of vibration. So that should have answered your first question. Why am I doing all this? Because I want to be able to hollow this thing without excessive vibration and without having to put a steady rest on it. So I need it to grip here. So that part's done. Yes? Yes? Well, the only reason it's been turned is because it had a hunk of bark on it, and I'm not going to turn a piece of bark in. Yeah. Well, it depends. If I'm mounting a bowl here, I don't have any stress on that bowl. I can just turn any old kind of tenon I want on it, assuming that bowl is, 10 or 12 inches or smaller. I'm not going to have a problem. If you do something like Mark does, and you got a bowl that's this big and this big, and when I put it on the lathe that weighs 85 pounds to start with, I want to make sure it stays on the lathe. So I want the tenon to be as strong as I can make it, and that's the strongest that I've found. And I've actually done this in various degrees, and you'll see the tenons come around here. I've done this various degrees and dropped hammer on this thing, and to return these tenons and dropped hammers on them. And I'm talking about a 5-pound, hammer, to see if it would knock this piece of wood out like a massive catch, to find a tenon in a process that I thought worked best for me. If you want to throw a spindle gouge on here and just throw it in there, and I'm also running a dovetail chuck. I don't run but one type of chuck that has shark jaws in it, so I can't answer to the shark jaw question. I don't know how to get the strongest tenon there, and how not to crush fibers. You want to compress these fibers to get a good hole, but you don't want to start crushing them, because once you start crushing them excessively, you start losing that. And in addition, if I have my piece like this, and it's got my tenon on it like that, okay, and I start crushing these fibers right here, what's going to happen is I'm going to get a fracture right there. And that happened to me for a long time. I was turning boxes in grain, and I'd get on the bottom of them, and I'd be tightening it up, and then I'd go to sand them, and I'd see the circle, and I went, where did that circle? Oh, I didn't get my tenon completely off, and I'd take another 1/16 of an inch off, and it'd still be there. I'd go, wait a minute. I'd take another 1/16 off, and about then I would see, instead of a circle, I'd see 4 jaws where they actually ripped the fibers, tightening them. So I'll talk about that in just a second. Did that answer your question? Anything else? If you guys have questions, just yell out. I'll be glad to answer them if I know the answer. And if I don't, I'll give you something anyway. It doesn't matter. All right. So this runs true enough that I can bring this up, because I don't want to pull it out of center again, because I don't want to weaken this part. Now, we're going to hollow it from the bottom, so we need a plug in the bottom. Normally, I take about 1.5 inches. On this particular piece, I have a limb that grew right there. I don't want it in the bottom part where I'm going to have to rechuck it. So I'm going to actually part this piece off up about here. But before I do that, I'm going to make a tenon on the end. So this is where we're going to work on the tenon thing. Tenons require 2 things to work well. They require the diameter to be proper, and they require the shape of the tenon to be proper. Are you on the overhead? Give me overhead. This tool right here that I made has a variety of holes. It's pretty dirty. Maybe you can see better on that side. These 3 holes here fit Big Mark chucks, which is normally I use. These 2 over here are Nova chucks, which I rarely use, but I have a hole. So I take this, I turn my lathe on, I set it right there just like that, and I say, I'm going to use that chuck right there. And I have a nice line. That's the diameter. That's a 50 millimeter diameter for this Big Mark chuck. Now I've got my size correct. Now all I have to do is get my shape correct. Here, we can pass that around. I don't think I'm going to need it again. The shape on the Big Mark chuck is dovetail. This is an old parting tool that I have cut the angles here to match this dovetail. It's actually about 1 degree narrower, so that it fits in here properly. And I'm going to use it to turn my tenon here so that it's shaped properly. Y'all weren't going to tell me about this, were you? You were going to wait till I had chips all down my shirt, and then you would say, hey, Jack, you ought to zip that thing up. And I'm going to answer your question right now. Jack, what speed do you turn at? I always turn at the same speed, and that's the speed I feel comfortable at that day. Some days that's 800, turning a particular wood. The next day, I may turn the same piece of wood at 1,200 RPMs. It's what I feel good at that day. So, but if you ask me, I will tell you what this thing up here says. No, I don't think so. All right, I've come right down to my line, but I've got this curve in it. Now I need to straighten this curve out. I'm going to use this tool. I'm going to stop this. Can you go to the overhead for me, Keith, if you're not? Okay. You see it? Yeah. See the corner right here? You see that corner right there at the top of this piece right there? That's as deep as I can go. If I go any deeper, I'm going to bottom out in this chuck. And the chuck ought to rest on this piece and this piece. That's what it ought to sit on. When it sits on this surface here, it ought to set. If you can't make it set absolutely flush, you need to have it set on the outside. On this piece here, if you can't make it sit absolutely flush, you need to make it sit on the outside so that as it tightens, it draws that chuck in nice and tight and doesn't push it out. Now, this tool gets used over and over and over again. So what happens is this little corner right here gets rounded off really quick. That's the first place these jaws are going to hit when they tighten up. What they're going to want to do is one of two things. First of all, they're going to want to push the piece out of the chuck, which is not going to give you a good grasp on it. The second thing they want to do when they tighten down is they want to tear those fibers right there and compress them too much. So what I do is I then take a spindle gouge and I take that little bottom out right there. It doesn't have any holding power right there anyway, so I've taken it out, just totally eliminate it. Now I don't have to worry about that jaw getting pushed off. I'm going to get a good grip. So now I've done everything I need to do to make sure I'm going to get the maximum grip out of this scroll chuck. I've shaped my tendon correctly and I've mounted it correctly. So now we can move on. Any questions about that? If you're having problems with those, take it and try it. I think you'll find that it works pretty well. It took me a long time I've never actually lost but a couple of pieces off this. I've lost one piece because I got a massive catch and it came out of a chuck. I lost two other pieces because the tendon broke off and they were cedar, and I tell people I don't turn cedar anymore because it makes me look bad. All right, now we're just going to part it in two. So I've normally come out 1.5 inches. I told you I went a little bit more. I wanted to get out of this knot here, which is not going to be part of the plug when I put a plug in the bottom. And that's what I'm going to use this piece for. That's a piece of dried maple. I bought a respirator in case it got too dusty. It's kind of like when cherry gets dry, it's kind of dusty. I don't part these all the way in two because after you break a couple of parting tools, little thin parting tools, you say, you know, rather than parting that all the way two to look good and breaking that $40 or $50 parting tool, I'll just go to a saw it in two. So. And I don't need any kind of mark on this end of it, so I did remember to mark it. Remember, I marked it here. I marked it here. Everybody see that? Down here, I can mark it on this tendon so I can get it all to line back up with a grain to line up. You'll remember where I put that because later when I start looking for it, because I'll forget. Somebody can help me out. All right, this stuff's a little bit dry. It tears a little bit on the end. I'm going to just take a second here and clean it up just a little bit. Wrong tool. All right. Now we've got the piece that we're going to work with. Now, what are we going to make out of it? How many of you guys are really good at form? I've got a guy, one of the members in our club, that is absolutely, he's, I don't know, close to 80, and he just naturally turns the most beautiful forms I've ever seen. Never measures anything, puts a piece of wood up here. I'm not quite that good. Actually, I'm not anywhere close to that good. But they make a little thing like this that'll help you out, but it won't, it's not exactly correct, because what your eye sees, one of those pieces still going around. Somebody hand me the tallest piece there. They sell, so other people must like them too. But if you'll measure it, you'll see that this piece right here doesn't come in at the widest place. It comes in where you visually start to see this part go down. You see what I'm talking about? The widest part is actually way down here, but your eye doesn't pick it up till here. So this will aid you, but it isn't won't definitely give you a nice looking piece if you go strictly by it. So what we're going to do, this is I don't know, Fibonacci caliber. You can buy them on eBay for about $15 or $20, or you can get the plans for free in 5 dozen places, and that's what this one is, homemade. And then you can spend like $1 for screws and build it. Okay, so if I go to the very top, and we're going to use this whole piece of wood here, and I go to the very bottom here, this tells me about right here is where I should be. But I just showed you that my widest spot is actually going to be down here, about here. Okay? Now, if you'll look, you'll see that the widest spot here is actually more like a third now. This is not exactly a third. So I'm going to leave this as my starting point. I'm not going to, if I don't have any flat spots in it, and I don't, I'm going to leave it pretty much untouched until I true the whole thing up. It's running true enough, I don't need to true it. Now, what I want to do is I want to come up with a nice shape down through here. And this shape accelerates down through here like a what's the word I'm trying to think of? Parabola, okay? It accelerates. If I start cutting off this, I'm more likely to end a nice curve. How many people in here have ever turned an egg? They're tough. They're tough to turn, nice eggs, because it's an accelerated curve. It accelerates the whole time. But I found that if I decide, okay, I'm going to turn, each time I turn, I'm going to turn, say, a 1/16 of an inch off to an 1/8 of an inch. If I turn it here, and I turn it here, and I turn it here, and you'll see what I'm talking about in a minute. It's maybe a little confusing right now. And I slowly space these out more. This is not an absolute given, but it will help you here get the shape right. So I'm going to start off turning it tighter, and then I'm going to get bigger. My bottom, I'm going to put a 1-inch hole in it, and then I'm going to widen that hole, so I want to leave about 1.5 inches on the bottom that I don't turn down to. And that little thing I passed around, that's what I need right now, so I'm going to guess at it. That's okay. I got it guessed. It's close enough. If I mess it up, it's no big deal. It's just a piece of wood, and it grows on trees. Now here comes the hard part. If you turned an egg, you know it's difficult. Has anybody ever turned these little garden dipper things that you stick in the ground that have got that long accelerating curve to them? What do they call it? Dibbler? Yeah, they're tough. It's tough to get a nice curve to this thing that doesn't have flat spots in it. Thank you. I'll just double check it here. Yeah, close enough. I guess I've turned enough of them now. So here you can use the tool of your choice. The easiest tool to use, I think, is not necessarily the best tool, is this one. So we're just going to start, and we're going to work it down, and we'll see where we get. It didn't center up right. That's good enough. It's okay. I'm going to start right here on that first line. I'm accelerating this handle away from me faster. Normally I would just lock this in and go into it. Like if I was going to true this whole thing up, I just lock it in right here and start down it. But here what I want to do is I want to come into my spot and I want to accelerate my body through it and start getting that curve that I want. I probably should have retrued this, but that's okay. Accelerate my body right on around. You see how I'm doing this? I'm coming in, I'm finding my bevel, I'm anchoring my tool, I'm finding my bevel right here, and it's bouncy because I didn't retrue it. I've got the tool in my hip right here, and as I advance it and it starts to cut, I'm bringing my hip around faster than I'm bringing the tool. So I'm actually ending up square here, whereas I started out here. I am right now. I'm going to have to get away from that because I'm not taking enough beat off of it. I'm going to have to. But one of the things I was going to tell you is if you have problems doing this, what you might want to do is put you a piece of cardstock right here where you cannot see this tool on this piece of wood. Because watching this tool cut that piece of wood is not going to tell you anything. What you need to be watching is the profile as it's forming. You know, when I used to fly, you know, when they put you under that hood for that instrument test, you don't get to see the outside. You have to trust those instruments. You don't want to see what your tool's doing here. You want to watch the profile on this wood. Because if you watch the tool, you're going to have all kinds of lumps and bumps in it. All right. You guys got the idea. Screw it up right there. And there I am. There's my line. I'm on it. There's a nice curve. If you want to know if you have flat spots or high spots in it, take a straight edge, lay on it, and roll it. Little high spot right there. You see that rock right there? What camera are you on? You on the overhead? I'll show it to you this way. See, it's got a little rock in it right there. What did? Oh, keep me guessing. What are we going to go to? Which one do you want to do? Okay. No, that's okay. I'll roll it right there. Right here is a little high spot. See it rock back and forth? Right here. See it rock right there? That means there's a little high spot right there. I got another one right here. So there's two. There's one here, one here. That means it's low in the middle. If you look at it, you can actually see a little bit of a gap there. And that's a good roll there. So now what I can do, I can't take the low spot out, but I can take the high spot out. This is a good place if you want a little skew practice, to practice your skew, Keith. I brought one. All right. All right, that's pretty good. You're not going to get it much better. Now, for you guys that are going to have problems here, let me show you how to cheat. This is made by 3M. They make a whole set of these. They come in, you get 4 of them in different shapes. I don't know what they cost. You know, I did body work for years and years. It's something that I acquired somewhere along the line. They are great, and I'll show you how they do. I don't want to stir up a lot of dust, but I'll show you how easy it is. There's one spot right there that didn't get sanded. That means that, yeah, I didn't want to stir that up. Now, if you're going to try this, let me warn you, start with 180 grit sandpaper. If you put 150 grit on there, you're going to put lines in here that you're not going to get out no matter how much you sand it. When you get it where you want it with this 180 grit paper, pull your tailstock away and sand it back and forth like this a few times, like you're doing a pen, like that, and you'll get all the lines out of it. And you'll have it. It'll look good. It'll take, if you're going to dye it, it'll dye without leaving scanning scratches in it. So, and I'll show you how this one works a little later. So that's how you do that part of it. Now I've got that done. Any questions so far? That's where I got them, somewhere along the line. I suspect you can get them off Amazon or eBay or anywhere else. Just 3M sanding blocks. Well, it should have been turned about 2 weeks ago. I like turning it when it's a little greener. It's a little too dry for me right now. I don't like it quite that dry. But yes, this part is dry. This piece is. You can do this out of green wood, and I do prefer turning green wood. I would, if I were going to turn it totally green, I'd do the whole thing and let it. I've got one that the neck's bent over like that. They take on all kinds of cool shapes. Okay, now, well, a bowl gouge has got a short little bevel on it. My bowl gouges do, and that roughing gouge will hold a line better because a bowl gouge is going to vary. It's going to vary if you do this or you do this. So there's 2 axes is going to be involved in a bowl gouge. And you get up on the wing, it's going to, this way or this way is going to make a difference. I prefer a bowl gouge, and at home, that's what I would have turned it with. But, you know, not everybody in here has been turning 15 or 20 years. Some of the people in here have been turning a year or 2. So I want to teach to them, if you're good with a bowl gouge, give it a try. If I were going to use a bowl gouge, what I would do is I'll come up here and I'll find my bevel, and I'll do exactly the same thing. When I get on my bevel, I'll accelerate that handle faster than that tip and keep working into that wood exactly the same way. I just think a roughing gouge is a little bit easier. Okay, I want to define a little something here. Somewhere up in here, I'm going to have a neck. Remember, we talked about you're going to start seeing the neck about here. I want to kind of get a visual reference to it. So it's going to start about right in here, really easy. I'm watching this profile over here. I'm staying off my high point. And I want to leave plenty of mass down here. Scrape that just a little bit and get what I want. All right, now I have an idea of what the top's going to look like. That's just, I want to leave this mass here to stop vibration. Now I'm going to drill a hole in it. Hopefully, we're going to drill a hole in it. I'm going to take the center point out of this rest, out of this live center, set it over here where I can lose it. And let's talk about the next problem you're going to have, drilling a straight hole. How many people can drill a straight hole that long in a piece of wood? How many of you own one of these things or own a long drill? You ever get a hole straight? No. The reason you don't get a hole straight is because the grain in this wood's not straight, first of all. And each one of these little pieces right here, give me the overhead, please. Each one of these things right here is your bevel on a drill. So what happens is that as it's going in, that bevel, and the bevel's there because if it weren't, you wouldn't have a drill, you'd have a screw. It'd just run in, it wouldn't cut the wood, it would just thread into the wood. And sometimes if you've got one of these in soft wood, you know what I mean, it runs in on you. That bevel's there to control that cutting edge, but what happens is the grains of wood start to hit it and it starts to push it off. And then you get excited and you keep going and it pushes it off more and more and more. My suggestion to you, if you're going to use this, is drill really, really slow with it and give it a chance to cut. The problem is it cuts better here than it cuts on the edge. So to solve that, I've gone to a gun drill. A gun drill doesn't have a bevel because it's made to drill steel. And it's got one drilling point right here with no bevel to support it. So it's like taking a bowl gouge and cutting off the bevel with it. Where do you want it? Right there? See, it's got one cutting edge right here. Okay? This one is a 5/16 because a 5/16 very nicely fits all the way down through there. So I know it's going to start in the straight. Now, the problem with drilling through a tailstock is if you do like a friend of mine who had it way out here on his, 6-month-old robust and drilled a piece of wet oak and then let it sit for 2 weeks, and I spent 2 hours Saturday getting his tailstock apart because it all froze up inside. If you're going to do this and drill it down through there, here's what you need to do. You need to retract this all the way back to where your live center is actually touching this piece and there's no way for anything to get into the threads. Okay, and I still would recommend if you're going to do really wet wood that you take the opportunity then to take your quill out and blow the ends of it out when you're finished. Another way to avoid that is when I bring this up, let me make sure it's going to run true. Okay, I bring this up, I'm nice and tight here to it. I'm going to start the drill in, and then I can pull this off so that these shavings don't end up inside this tailstock. I only want to go down, not to my widest point, but past that, because I'm going to re-drill this thing in a minute. So I'm going to want to go down about that deep. We're going to have to measure it. I'm going to show you how to do it. This is made to run lubricant through it when they drill gun barrels. It runs lubricant down through it, and it comes back out the slot. We don't do that because we don't want water in it. I'll run air through it. The one time I'm going to look, I want about 500 RPMs, somewhere in that neighborhood. I can stop, I can come off, so that I don't keep running that stuff down. Let me pass this around. This is designed to cut steel. That's what happens if you forget to take the center point out. It will go through it. I don't know how deep that is, but it's deep enough. What did I do here? There we go. That hole, I should have gone slower, but that hole will be straight, or it will be pretty straight. Okay, let's go with that. That is to assist the real hole I'm going to put in it. Which is going to be a 1-inch hole. This is really a metal bit, so you're faced with these facets here that are going to push you off if you don't put that hole in there first. This looks like it'll go in there straight because it's big and it's heavy. It will not, trust me. We're going to go down past our high point to about here. Is there a clock in here? Thank you. I went to give a demo, and I'm not going to tell you which club, and what they wanted to see. I said, guys, I got to have a minimum of an hour and 15 minutes to do that. They said, oh, yeah, we'll give you an hour and a half. We will. I said, okay, but I got to have an hour and 15 minutes. That's what I got to have if you want to see this demo. They meet in a place they have to be out of at 9 and 8:15. He says, your turn. That's 45 minutes for y'all that can't do math. I said, okay, you get to see an hour and a half demo in 45 minutes. All right, about 500 RPMs again. It's nothing to it. We're just going to drill it out. And I may not even drill it all the way. Let me do one other thing before I get started here. Let me make sure this drill bit will stay in here. It's embarrassing when the drill bit comes out. And it may come out anyway. I drill until the shavings quit coming out. No, you can use a Forster bit. They're just expensive and they get dull quick. So they're fairly easy to sharpen, but I just don't use Forstner bits that much. I can't tell you why. I guess first of all you got to put an extension on it to get down in that deep because nobody makes a Forstner bit that long. And you can buy one of these on Amazon for about $30, and I've had this one for years and years and years. You know, I don't have to put it in a chuck. I don't need a Jacobs chuck here for it. It's got a number 2 Morse taper on it, so I just knock it in there. Here, it's just a lot quicker and easier. If this thing starts to squeal and it's like that, it's annoying. There's a couple of things you can do. I forgot my wax when I went to the Florida Symposium. My wife said, well, why don't you get some soap? So I got a bar of soap from the, we'll try that, see if it works. Just put a little soap on it. I didn't forget my wax tonight, so if it doesn't work as well as the wax, we'll go a different route. Here's another thing you can do. I always put my bits after they're hot in wax paper. You can take some wax paper and just put on it a little bit. Give it a little lubrication. I'm almost there. Only a little bit more. That's enough. Do it. Clean your bits off because they're going to have sap on them. And if you put them away with sap on them, the sap's going to get hard, and then when you go to use it again, it's not going to cut the way it was cutting, and you're going to wonder why. All right, so now we got a starter hole. So here's my piece, like this. Okay, we've got a hole in it. The next thing I want to do is I want to, before I start to hollow it, is I want to put a recess, a mortise for the tenon that I'm going to put in the bottom, or the plug. And the way I'm going to do that is I'm going to come right here. I'm going to go in about 3/8 of an inch that way and about 1/8 of an inch this way. This wall and this wall down here have to be perfectly square. If they're not, when you flip this thing around and you glue it up and you go to turn the other end, the glue joint's going to fail on you. That has to be perfectly square right there. Here and here have to be parallel, and I'll show you how to do that. Now, I used to hollow them first. I didn't want to weaken it down here. I want to hollow them first, and I found out when you start to hollow this thing, it doesn't always necessarily turn true. So the inside where I was hollowing is nice and true, but the outside's wobbling all over the place, which gives you a problem later. So if I make my mortise now, while it's still true, I don't care whether it goes out of round, because when I turn it around and re-glue it, it's going to recenter it. Does that make sense? Do you understand that? So all I'm going to do is a scraper works well. You're going to find as you start to go in here, what's going to happen is the deeper you go here, as you go in, you're going to end up with something like this, because that tool gets pushed away from that wall as you're hollowing. As you're going in, it's getting pushed away, so that will not stay square. So you have to really run the tool in. Instead of running it in straight, you have to run it in at an angle to get an end result that's square. I'm on center. This is a scraper type tool, so I want to be on center with it, or slightly above, just not below. Can you see that on the tailstock end? Down in there. All right. Here's the way I'm going to determine that it's square. Harbor Freight set of calipers. Set it in the very back. If I've got it square, it's going to be tight all the way out. But see, it's loose right there, and it's tight back there. So I don't have it square. I need to take some from about the middle of the joint down. Not quite, but close. So don't quite have it. And there it is right there. That's pretty straight all the way. I have about the same slop in the bottom as I have in the top right there. So that part's done. Now I can go to my hollowing. Now, yes. Yeah, if you're going to do that, start off with a Forstner bit and cut that piece right there, and then go to a smaller one and go down through the center of it. Yeah, but what's required there, Loretta, is it requires when I'm doing these to stop and go get the Forstner bit and all that other stuff, and that takes about a minute. That's like people say, well, I use a threading jig, and I said, yeah, well, by the time I set my threading jig up, I could already hand threaded 5 pieces because it takes so long. Yeah, use the bigger Forstner bit first, okay, for the outside, and then take the smaller whatever bit you're going to do and go down through there. Okay. Now you can hollow it. I have found that depending on what kind of wood it is, we hollow it for a reason. We hollow it so that when we finish with it, the weight feels right. If you're going to put it on a shelf or you're going to give it to your, in my case, my sister, every Christmas I send a whole box of this stuff to my sister, and I say, good, it's off my shelf. If you're going to give it to somebody, they don't know anything about wood turning, forget the hollowing. You got a hole in it, you lighten it up, go on, because the hollowing is what takes you the longest time. But I'm going to show you how to hollow it. It's not necessary to hollow it. It's always easiest if you have some kind of stabilizer to hollow with. Mark, didn't you find that your Trent Bosch didn't fit this? Oh, I thought one time you tried to use it in. Well, mine's not going to fit either. It's way too low. It's way too high. Okay. So maybe we're going to have a short hollowing session here, because Jack doesn't like the hand hollow, but I will. Give me just a second and let me readjust here. When I teach students how to hollow, I always make them start hollowing by hand before I ever let them have the benefit of a stabilizer. Because if you start with a stabilizer, you never really totally understand what's happening up inside when you're hollowing, when that thing's jumping all around in your hand and you get afraid of it. You don't quite figure it out. But if you start by hand, you have a better feel for what's going on. Once you get past this first part right here, and you get the wall thickness that you want, that ain't it. I think we lost our air pressure, but that's okay because I'm about done with it. I would go thinner than that, but at the very bottom I do generally leave it a little thicker because I want the support. I usually go 1/8 of an inch down through here, but what you can do now once you establish that first part is get rid of this thing that's hard to use. Get one that's much easier to use, a nice straight one. And since this thing's almost straight, you can run right on down that wall. Now, watching somebody hollowing is kind of like watching paint dry. We're not going to do that. If you need a hollowing lesson, see, Mark, raise your hand so everybody can identify you. Mark will give you a hollowing lesson. All right. Let's say we've got that hollowed. And we're done with the air. We're done with that. We're done with that. We're going to take this out. We're going to put our plug piece in. Remember, I marked the same spot. I'm going to put the plug piece in. I'm going to put it right here. 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 Just out of habit, I'm going to put it in the same spot. I'm going to put it right there. Okay. Thank you. How many people like number 1? How many people like number 2? How many people like number 3? How many people like number 4? Okay. Number 1. See that little dark spot right there? There's a little dark spot right there. That means that this tenon was a little too big, and that jaw did not get 100% grasp on it. You see the dark spot here and here, and it gets lighter over here? This did not square up in the chuck square. Let's go to number 4. Number 4 looks pretty good. It got good contact here all the way around. That doesn't matter. It's probably in the wood. But you see right there, it's got a dark spot in it, which means, again, the tenon was too big. You can tell that by the gap in it. A little bit too wide a gap. Okay. Number 3, it's undercut. That's not too bad. It pulled up good here and here. It did not pull up good there. And here again, the tenon was too big because I've got a dark spot right there. All you people that had number 2, pat yourself on the back. It pulled up good all the way around. There are no dark spots. Now you see how much space is in between? That's the perfect size tenon and the perfect shaped tenon to get the best grip you can get. How many people passed? Y'all passed. I'm easy. Everybody passed. You know how to make a tenon, you pass. All right. I'm going to face this off. And I'm going to put a little indentation here while I'm here in the middle, right there, and you'll figure out what that's for in a few minutes. All right. It just so happens that I use this, remember, to check that. So I already have the diameter here. I can just put it up there and scribe one edge of it. That's a little bit big, but it's a good place to start. Bow gouge, catch it on the wing. Is it warm in here? Almost there. You notice how I'm doing this in stages? If I make it too little, I don't want to have to back all the way up to here. And there it is right there. So all I got to do is square all that up, and I've got it. It's a little too tight. If you have it too tight, you'll end up pushing all the glue out, and you won't have that good a joint. You guys that have made furniture, you know what I mean. And that should do it. There we go. Now what's happening is this piece is going down and it's resting on that little lip that I left in there. So I've got a good strong bottom. Now what I will do is I'll find my mark down here. Thank you. Where did my center point go? Is it floating around here somewhere? Thank you. There'll be extra brownie points for you later. Yes. Nah. Glue's porous enough. I've never. The only time I've ever had one of these fail was when I did a bunch of them one time. My wood was a little green, and I used Type Bond, and Type Bond does not work well on wet wood. They all failed. So I quit doing that. I use super glue now. Now you can force the center because you want it to be in the center. What I'm going to do is I'm going to bring it up. I'm going to find, I think I'm going to bring it up. I'm going to find my mark here. I'm going to find my mark down here, right there. I'm going to look right here at the end, and I'm going to line up my grain. And when I get my grain lined up, I'm going to take my pencil again, and I'm going to be real careful about looking at it, and I'm going to get it perfect and make sure that all the spot lines and everything line up, and I'm going to mark it. I'm going to come back to my spot here, and I'm going to mark it right here where I can see it easy, and right here where I can see it easy. And I can sand those pencil marks out later. Take it apart. I'm going to take my super glue, and I'm going to put it right here really thin, and I'm going to take something like my finger. No. Like, I'm going to take something, I'm going to smear it out. I don't want a glob of it there. But where I am going to take it is just inside this lip here, and I'm just going to go ahead and pile it in, because what's going to happen is it's going to be like a piston. It's going to push it all in. I'll go ahead. You can't use too much super glue in here. It's just going to push it in. If it pushes a little bit of it out, just take a paper towel and spin it and rub it off. Okay, you're going to work on this end again later, and we'll get to it. Then put it up, center it up. You're going to pull it up nice and tight so that it bottoms out. Okay, then loosen it up just a little bit so that the glue has a place to sit. You know, make sure it's running true. Go have lunch, or spray it with accelerator if you want. I'd rather go have lunch than have accelerator. And now, through the miracle of the cooking shows, it's glued up. The reason I'm not going to finish this piece is because if I finished, I'd have to hollow it, or I'm going to have an inferior piece. I'll finish it later, and it'll be a nice piece instead of something I rush through. We'll finish this one up instead. Actually, that's not true. We'll finish this other one up instead. So we're going to go one more piece. Chuck key there. All right. So we've got this piece. It's in here. It's glued up. Okay. Let's check it and see if it's still running true on this end. Nah, it warped. That's okay. We'll deal with it. We're going to take it out of this, and we're going to spin it around. We're going to use this tenon on this end. No, I'm sorry. I had it right. We started out here, okay? We spun it around, we glued it. It's late. I'm easily confused. All right, so let me see if I can get it right back in this same spot here. That's pretty true. Good enough. All right. So this is where we're at. This line right here is where I actually carried that drill bit to and where I hollowed to. There's my high point. There's that. All I've got to do is put a hole in the end and finish this up, spin it around, and take the bottom off. Okay, so now's a good time to put the hole in this end. I'm going to do the same thing I did before, except that it's not running exactly true right now. So I'm going to take the center point out. This is a nice little tool to make yourself. It's a rod out of a printer, and everybody's throwing printers away because it's cheaper to buy a new printer than it is to buy an ink replacement for one. And it knocks the center out without having to take the thing back out. I'm gonna come down here with I'm gonna bring it up, but I'm not gonna, since it's not running perfectly true, I'm gonna bring it up to there. Oh, what happened here? There we go. It's got some, yeah, it's got some wood crud in it. This hole actually needs to be straight. The other one wasn't that critical because we were going to hollow it anyway. We're not going to hollow this again. If this one's not straight and you make a real thin neck, I just went through it, you're going to go through the sidewall of it. All right, there's our hole. I'm going to force this thing to run true on that hole now. By truing up this face right here. And you know what I think I forgot? Wasn't there a, does anybody know where the end is for this live center that I took out of this machine? Inch in the back of me on the right. I do not see it, but am I blind? You talking about this? No, that's not what I want. I want the cone, the aluminum cone that screws onto it. All right. Well, we're just going to do it. I mean, that was it, what was in there, but it didn't have the cone on it. Okay, well, let's do it the hard way. I've never done it this way. Life's an adventure. What I'm going to do is I'm going to bring this, I'm going to have to change around a little bit. Normally what I do is I put the cone in this hole, and then I know it was running true. I don't think I brought it. I think I left it. I think I left it at home. I can make it work. I don't ever expect to get to a demo and have everything I needed. There's just some unwritten rule about that doesn't happen. Okay, if I take the same Fibonacci thing here and I say, okay, I measured this out from here to here. There's where my neck starts to appear. If I come up here and I measure it from here to here, okay, right here would be a good spot to have my lowest point on my neck. See how the neck starts down, but the skinniest part's right here? That would be a good place to have my skinniest point right here. The question is what size am I going to make my top up here? Well, if I come here and I measure the outside diameter of this thing like this, okay, that would be a good rule to make my centerpiece. And you can see how precise I really am, you know. All right, that's close enough. So that's what I'm going to make the rim of my hollow form. So let's start there. go back to my detail gouge, and I would normally have a cone in there supporting this, which is better than what I've got here, but we'll give it a try. Worst thing happens is, can you catch? Okay, good deal. The angle we're going to put on this is going to be dictated by how close we can get in here. So I'm just going to start working this down. I'm starting with these flutes perfectly vertical. If I start off one way, this tool is going to run and tear the rim out. If I start off the other way, it's not going to cut. Now, normally what I would do is I would cut that on through that wall. I'd pull this tailstock away. I'd round that up where it had a nice entrance point. I'd put a piece of paper towel on that aluminum cone so that I didn't mark the wood up, and I'd put it back in and use it as support. I don't want to cut it away right now, because if I do right now, then I'm not going to have the support I need to finish this neck. So I'm going to turn it around. I'm going to finish the neck, then I'm going to cut that out last. So just trying to overcome a few problems here. All right, so let's come up with a shape. We pretty much want to follow this inside down. So I'm looking at my inside angle, and actually, I'm going to see if I can get it a little steeper. It's a little shallow looking to me. See if I can get in here just a little bit. One more cut. There, that's better. All right. See here. All right, come back here and try and. That's bouncing, and what's bouncing is the bevel, because it's not round. If I'll slow this down and let that tool move in and out like that, I can come off that bevel and get it true again. See that? I can retrue it. That means that this part right here will be a little messed up. Probably have to sand it out, but it lets me go back to being on the bevel. I'm going to guess my low spot was going to be about right here. Somewhere in there. And I'm going to work to that spot. What's my time? Thank you. Anybody have any questions what I'm doing? I'm coming back here. I'm finding that bevel that's starting to bounce. I'm getting past that bounce. I'm moving that tool just enough where it starts to cut, and then I'm just riding that bevel right on down. And I'll check my low spot here in a minute. These are so when the tool doesn't roll off and stick me in the foot. That's never happened. I'm sorry? Those are, I actually bought those a long time ago. I don't think you can get them anymore. They were made for putting your gun next to on your pickup truck so it didn't fall over. I haven't seen them in years. I've been thinking about making them and see if there's a market for them. I haven't been that industrious. Okay, there was my line. So I'd say I'm a little high. We'll come down with it just a little bit. Doesn't look bad though. I'll take it right on down a little bit. That hole I put in it was a 5/16 hole. I'm going to change that hole in a minute to a 3/8 hole. So I want to make sure that my neck here stays at least a 1/2 inch. Get a few tool marks out here. Okay. If you don't get those curves just right, break this thing out. Take it right here like this. And you got it. And I'd have to sand that out right there because that's where it goes from being true to being untrue. So that part, now the neck's done. All I need to do is finish this up, which normally I would have already finished up. But I'm going to finish it up by going through it, hoping that it continues to run true when I pull it away. I'm going to open that up. Does this slide off easily? It's going to be a little bit wobbly here. Go slow because you don't want to tear pieces of it off and have it go down in there, because if you do, if you tear pieces off and you knock them down in here, sometimes they don't rattle out, and then what you have to do is hold it up, put your little tight bond in there, wiggle it around and set it aside and let those pieces harden up. That's right. Let me get this a little bit better. If you get a catch here, you're going to knock it out of the chuck. Normally what I do here, I'll just show you if I've got a piece of sandpaper with me. I do. sandpaper. Roll it up. I need to true this edge up because I didn't do that a minute ago right here. That might be hard. I kind of lost step here. I should have done it earlier. I think it'll be okay. There we go. All right, the top part's done. We would have sanded it and do all that other stuff. Now we want to turn the bottom off. So let me pass this thing around. You guys can look at this because I'm fixing to use a bigger one of the same thing. Nope. You lose. It rattled out. All right. So this one is to all the same places that one is, only it's been sanded to 320. We're going to finish it up. It had a check in it when I started, so when I finished that nice big rim I have on it, a piece of it just fell off, and it fell in about, stuff that deep. I never found it. So I just redesigned it. Okay, so this thing right here is the same thing you've got there, only bigger. I've got the number 1 jaw marked here. It goes in here with that number 1 jaws right there. Just like that. You get a snug fit on it. Like that. This rod, as you tighten this up, it will tighten this rod up. Remember I put that, when I had that plug in there, you remember first thing I did when I faced it up is I put that little indention. Well, that little indention is right down here in the bottom, and it's going to help when this thing goes on here. It's going to help center up this bottom piece. Now, this doesn't run perfectly true. Everything's making a liar out of me tonight. When I tighten it down, it's not going to run perfectly true. If you want to make one of these, it's real simple. You just take a block of wood. You can see you slit it. You put a tenon on it. You slit it. You make a cone shape out of it. Start off with drilling the hole first. Okay, and then use your centers to turn everything off that, and it'll be fairly true when you finish. Won't be perfect. You need to use something really hard, hard maple, dogwood, persimmon, or Osage orange is what I found works best. Okay, I've got that. I'm going to bring my center up, and guess what? We don't have a center piece for it, so we're going to have to kind of guess at it. See if I can get it centered up here without a center point. Now, I picked this piece on purpose. You were asking me about green. This was turned when it was green. See how much it's moved? It's also not round this way. So it's going to be a challenge down here. I always enjoy a challenge. So this will spin. There is nothing tight in here. It's going to spin on you. The way to stop that is my miracle fix-it-all. Is some tape. If it spins, it's going to burn your wood, tear your tool up. If it's wood on wood here, it's going to burn it. Just start off by taping your piece. Do what? You know why it's yellow? You know why I use yellow tape? Because I go to body shops every day doing my glass business, and it's free when you pick it up. Say, hey guys, I need some tape. Somebody hands you a roll. I also have orange and green. I'm well color coordinated in the tape market. But I like free. Free's good. Okay. So there we have it. Yeah, this ought to be fun. All right, let's start off by getting rid of some of this waste stuff that we're not going to do anything with anyway. You got to make light cuts. If you don't make light cuts, you're going to tear your tape loose. The nice thing about the rod going all the way down through here is it's not going to spin out in there, but it may break it. So you don't want to get too heavy-handed. All right. We're going to slow this thing way down since it's so out of round. And I'm going to try and get on this bevel and see if I can do this without having to use a whole lot of sandpaper when I'm done. That's all completely on the bevel. See the tool rocking back and forth? I'm going to make that tool start to cut. And as I make it cut faster and faster and come off that bevel, it should quit bouncing as much. Didn't quite get it all, but we'll back up again. All right, that's probably good enough. Come around here. All I'm really doing now is just kind of turning a cove so that I can get this thing squared away here in the bottom. Now I'm going to stop here. When I get that cut off, it's going to be hard to sand, and I don't like hard to sand, so give me just a second, and I'm just going to kind of smooth this out a little bit so that I don't have a lot of sanding to do later. My glasses are starting to fog up. So I got a really good challenge going on up here. When I get one of these really right, I end up nice and smooth where I don't even hardly have to sand the bottom. I will admit this one's more of a challenge than most, though. Hardest part here, getting the tape off. The what? That's true, but it doesn't hold nearly as well. Yeah, it's not free. I don't know anybody that uses blue tape. Questions? No, this is still running pretty true. It's off a little bit. No, I turned it green. I turned that one several weeks ago because I didn't want to get jammed up on time. I didn't know how long it was going to take. Normally I take an hour and a half to do this, and I do one piece, but there's a lot of it I didn't cover as intensely, like making the tenon and stuff, and the people tell me they have problems as it vibrates and it does all this other stuff, so I knew I had to back up and cover some things a little better. So, plus if you blow a piece up and you have some other pieces to take over, you don't look nearly as silly. Yeah, it's a piece of foam. This piece right here, yeah, glue a piece of foam on it, take your skew, cut it to the shape you want. So, anybody else? I'm, oh well, I wouldn't pay 159. So some shop probably bought it for me. Take you a block of wood and put your little piece of rubber on it. It'll work just as well. I said I wouldn't pay $159 for those four little pieces from of like this. Just take you a block of wood, take you a piece of like inner tube rubber and glue to it, and then or some type of thin foam. They make I bought a whole pack of really thin single-sided stick foam at Michael's, and I use it for a lot of different things. You just stick it on there, and then instead of using this Velcro stuff, just get you some PSA paper, pressure-sensitive paper, and you just stick right on top of it. You don't want to go the paper right on the wood, because what it'll do is it'll just burn spots in the sandpaper, and it won't sand very well. It needs a little cushion to it. But I wouldn't spend $159. I'm glad you told me that. I won't market it anymore. To heck with 3M. Other questions?